Good evening, children. Today we are discussing acidic character of carboxylic acid. General formula of carboxylic acid is R C double bond O OH, and carboxylic acid in presence of water this one will lose a proton, which this one will accept. So this is the equilibrium that will be there. So this is aqueous, this is also aqueous minus. This is liquid. So this is aqueous. So, because of this equilibrium, we say that carboxylic acid is acidic in nature, and of course this is a conjugate base, and more stable the conjugate base, more acidic will be the carboxylic acid. This is a very important thing you should remember. More stable the conjugate base, more stable the conjugate base, more acidic the carboxylic acid. So this you have to remember. So let us take as an example, say we have two acid, one is CH3C double bond OH, and say another is HC double bond OH. This is acetic acid, this is formic acid. So which of the two is more stable? Which of the two is more stable? So we will take the conjugate base of them. The conjugate base of this one is CH3 C double bond O minus. In O minus, there will be there are 3 lone pairs. Here also there will be 3 lone pairs. This is the conjugate base, and conjugate base of formic acid is HC double bond O minus. Now, which of these two is more stable? You can see that alkyl group. This is an alkyl group. Alkyl group has plus I effect. Okay, it has got plus I effect, electron releasing inductive effect, and this will lead to more concentration of charge. This will lead to more concentration of negative charge, and this will make the conjugate base unstable, whereas such thing doesn't happen here. So we can say between these two, this is more stable, this is more stable, this is less stable. Since it is more stable, so this is more acidic, and this is less acidic. So what we have seen is that formic acid is more acidic than acetic acid. Suppose you are asked between aliphatic acid and aromatic acid, which one is more acidic? Between aliphatic acid and aromatic acid. So this will form one example of aliphatic acid, and benzoic acid. Benzoic acid is one example of aromatic acid. So which one is more stable? between this, which one is more stable? Not stable. Between this, which one is more acidic? Aliphatic carboxylic acid or aromatic carboxylic acid? The answer is this one is more acidic. This aliphatic carboxylic acid is less acidic. The reason is that the conjugate base of this one it is so the conjugate base of this aromatic acid is this one, and this aliphatic acid is this one. Now, as you know, this alkyl group, as I already said, it has got plus effect, whereas this benzene ring, phenyl group, it has got electron withdrawing effect. So here the negative charge will get concentrated, whereas here the negative charge will get delocalized. Because of this electron withdrawing ability. So this conjugate base is more stable. So this one will be more acidic. This conjugate base is less stable, that's why this is less acidic. So we are clear that between aliphatic carboxylic acid and aromatic carboxylic acid is more acidic. Okay, now there are many questions which comes of this type. Suppose you are asked to explain the acidity order. Suppose you are asked to explain the acidity order. This is chloroacetic acid, this is dichloroacetic acid, this is trichloroacetic acid. So, how to explain this acidity? Suppose let us include this here also. So, this one, So, the acidity order is like this. So, this can be easily explained. It is because here there are 3 chlorine, and this 3 chlorine has got minus I effect, and because of minus I effect, the conjugate base, the negative charge on the conjugate base will get more delocalized. So the conjugate base out from here will be more stable. So that's why this carboxylic acid will be most acidic, and then next it will be this one because of 2 chlorine atom, then it will be this one with 1 chlorine atom, and this one will be least acidic out of all these. Suppose you are asked about this case that say CH2 COH F. This one is chloroacetic acid. It will be more acidic than this one. this one will be more acidic than and next will be more acidic than CH2. So here we will answer in this way. It is because why this one is more acidic, because fluorine is more electronegative than chlorine. Chlorine is more electronegative than bromine. Bromine is more electronegative than iodine. So here the conjugate base will get more stimulates than here, than here, than here. Because you know the position of these halogens in the periodic table. It is fluorine, chlorine, bromine, iodine, and we know that electronegativity decreases down the hill. So, like this type of question to explain the order comes in exam. Say another such case which I am taking up now is say this compound will be more acidic than this compound will be more acidic than this one. This one will be more acidic than this one. This one can be explained this way, like here halogen is at alpha carbon, here halogen is at beta carbon, here halogen is at gamma carbon, and here the minus I effect will be strongest out of the three. Here the minus I effect will slightly be less because distance has become more. Here minus I effect will be even less. So in this way we can explain the acidity order of these halogen acids. Okay, now children, you have seen in the previous chapter that phenols are also quite acidic. Phenols are also quite acidic. Now, so we'd like to compare here the acidity of carboxylic acid and phenol. Okay, so now let us compare the acidity of carboxylic acid and phenol. You know, both these substances turns blue liquid paper red. So let us try to find out which one is more acidic. Now, as you already know, conjugate base of carboxylic acid is carboxylate anion, whereas the conjugate base of phenol is phenoxidine. So, let us draw the resonance structure of phenoxidine. So, this is phenoxidine. So resonance will take place in this way. This lone pair will come over here and this one will come over here. So a double over here, O. Now two lone pairs. Here the lone pair will be here and this carbon will be minus. That means the negative charge which was there on oxygen, now it has come on this carbon. Next, this 2 electron will form a bond here. This pi bond will break to come here. This way it will go on. Next it will come here. So we see from this resonating structure the negative charge is nicely spreading to different positions, and finally it will come here and go back. The negative charge is spreading. And as far as the resonating structure of this carboxylic anion is concerned, carboxylic anion, so that also I am trying to draw a resonating structure of carboxylic anion. It is R, C double bond O. So what will happen is this chemical will come here and this one will here previously there are 2 lone pairs, so now it will be three lone pairs here and a negative charge, and here it will become double bond, and we will not get any more structure. So we are getting 2 structures. Carboxylic ion has got 2 resonating structures, whereas phenoxide has got many resonating structures. But apparently it may appear to us that phenoxide is more stable because of so many structures, whereas in case of carboxylic ion there are only 2 structures. But it is not like this. It is because one can see that the negative charge is lying on carbon. In this structure, negative charge is lying on this carbon atom, negative charge is lying on this carbon atom, but we know carbon atom is not so electronegative. Since carbon atom is not so electronegative, these structures though we have drawn, these structures will not be so important. These structures will not give so much stability to the resonance hybrid, because carbon is not so electronegative. On the other hand, here in these structures we see that the negative charge is on oxygen, which is pretty electronegative. So these structures contributes a lot to the stability of resonance hybrid. So that is the reason why carboxylic acid is more acidic than phenol. As I already said, this and this both turns blue litmus paper red, but this one is more acidic than phenol. Now, question naturally arises how to distinguish between carboxylic acid and phenol. This can be done. We can do this distinguish by sodium bicarbonate test. Sodium bicarbonate test. With the help of sodium bicarbonate test, we can distinguish between phenol and carboxylic acid. So there occurs a chemical reaction like carboxylic acid, it decomposes sodium bicarbonate, and the product is RC double bond O minus Na plus carbon dioxide plus water. So in sodium bicarbonate test, in case of carboxylic acid, there will be a brisk effervescence of CO2 gas, whereas phenol and NaHCO3, there won't be any reaction. Phenol and NaHCO3, there won't be any carbon dioxide liberation. So carboxylic acid and phenol can be easily distinguished by sodium bicarbonate test. In fact, sodium bicarbonate test is a very good test for carboxylic acid. Now, discussion on acidity of carboxylic acid will not be complete if I don't discuss about the term called kK and pK. Suppose this equilibrium, then equilibrium constant Ka is concentration of RCO minus, concentration of hydronium ion, concentration of RCOH. This is called acid dissociation constant, and stronger the acid, stronger the carboxylic acid, greater the Ka value. Stronger the carboxylic acid, greater the Ka value. Now there is another term we often use, that is pKa. pK is defined as minus log of Ka. pK is defined as minus log of Ka, and here what ultimately becomes is stronger the carboxylic acid, okay, lower the pKa value. So this you have to remember, and as far as aromatic carboxylic acid is concerned, the presence of electron withdrawing group in the ring will increase the acidity, whereas the presence of electron releasing group as usual will decrease the acidity. So this much is for acidity of carboxylic acid. Okay, I hope you have understood all these things. If you have a doubt somewhere, some questions, you can certainly ask me tomorrow. Till then, good night.